Hi everyone. Today I'm super excited that I watched the let's say the AnomaVision in a Google Colab. So now you can train, export, and detect on a Google Colab. So to run this efficiently, you have to run it let's say on a GPU. So you need to change the runtime type into GPU because the default is sometimes it's a CPU or from this here, or you can just click and this one here change the time, the runtime. So now let's see if we have a GPU. Sometimes you need to if you already clone the repo, you need to remove this because when you clone it again, it will just create a nested folders, which is I will figure it out. I'm not let's say expert with Google Colab. So now let me now clone this repo here, which is this one here, because currently it's not let's say stable. So I'm just using this. It's just now testing, and the most interesting let's say stuff here is that the running time, it will make you surprised. It's about 2 milliseconds, exactly 2 milliseconds. So you can process more than 400 image per second. So now let's see, check uh, the, the GPU size. I have 15 GPU memory, and here you can see this is the image. I mean the node the numpy image is the most important stuff. So if it's 2.02, because the Google Colab, it has already installed this, and if it's 2.2, it won't work. So what you have to do is just install this one here, click this, and restart the session without any installation, and start from, for example, from here. It will give you the exact result. So now I would like to make it, let's see, real test. So I will just load the OK images, and for the test I will try to load some other, let's see, test. So because this will take a bit time. So now this is the config file, the configuration. This is the common configuration, and you can see this is the uploaded image that I'm currently uploading. Class, bottle size, resize, crop, normalized, main, and everything. This is already clear from the last walkthrough. For the training, it's the same. And the interesting stuff here, it's quantized in the export model. And last time I have exported in quantized in integer 8, and I showed also the result in C++, so you can have a look. And now let's upload the images. It's still not uploading. Let's just move to the. So now here, if you would like to have some logs, some logging, because the AnomaVision has a log, but without explicitly, it won't show you anything. So it's good to have the logs if you would like. And this is for the training. This is the export stuff, and hopefully this won't be needed. But if in case you it's tell you that it's missing, you need to install this. So as I said, I'm not expert in the Google Colab, so I'm still learning indeed. Let's see. Okay, now I see it's loading the images, and the running time, the after the training, we have to do the detect. So you can see the detect. I will profile the whole setup. Let's see, most of interesting stuff. It's inference, and you can see I can test several models, and also here I can visualize the result. I will just show you in a minute. So hopefully this won't take much time. So this is already done, and I will just load some test images. Let me make it clear. I will just upload these images. Now let's try to run config file. Now let's see, do our log train. Hopefully it should work without any issues. Okay, now it's the model, it's already saved. And why there's no files? Oh, let's try now. So we need to export the models. It's completed, and you can see that the model, ONNX model, is 15 megabytes. Oh, now it's showing. Okay, now let's do the testing, and for this I will start with PyTorch, and for the visualization I will try to not to visualize. Yes, I mean just in the beginning. So now you can see the running time now is 3 milliseconds, and if I run again, okay, I have also the warm up. Yes, now as you can see here is, I mean, in the previous experiments, indeed, it was one this 2 milliseconds. But at let's see how many images you can process per second. It's 270 images per second. And if you open the images and the normal, let's say the normal frame rate per second is 60 image per second. But you can see now our algorithm can process 300, almost 300 frame per second. Okay, now it's 345. So it depends on the load indeed. But let me now try to use another model, which is, let's see, by the dictionary of the PyTorch. And let's run this. And you can see I can process 400 image per second. So now someone will say I need to see the result, which is of course we need, of course, I mean, this is not about running time, it's also about the accuracy of the result. True. Let's see, now run this, and now you can see this is the affected images, and now you can see now that the time it's about 10 millisecond. Why it's 10 millisecond? Because the visualization is done in the same, let's say, thread, in the main thread. So this could be also improved if we move it into another thread. And let's see, and even with that, with this delay, it can process 215 images per second, which is quite a lot indeed. So what is I have, let's see, some issues here, not issues, just it's not, let's see, logic. When I use ONNX now, ONNX model, and let's try to see the why is this now. What's this here? Okay, that's only this one. We can see with this and we can remove it. Okay, copy. And just to see with this one here. Why it's just go down. Okay, now we can just change it to print. This is also fine. So now you can see I will just clean this. Clear. Now test missing required parameters as element type. Element type. Okay, this is the latest changes I have done, which is make everything is defected indeed. So I will try to fix it. What I mean by this is you can see here in the AnomaVision Inference model backends and the ONNX. Here I need the model. Where is it? Predict this element type. This needed here. So I will just fix it and come back to you again. Okay, now it's working as expected, and as you can see here, this is the running time of the ONNX. You can see this is the backend ONNX, and this is the number of images that have been. Let's see the inference time, and here I can process 700 image per second. And as you can see here, what I have just changed with this element type here. So it was in the beginning 32. I mean 16 or 32, but just change it to, if it's sometimes if it's the model itself, if it's F16, it has to you have to convert the image into let's see F16, and if it's F32, you have to use F32. And let me now just show you the inference time of the ONNX when it's let's see um, not let's see floating point, which is the default let's see precision is F32. Now let's see export, and if you see now, no, it's not working. So let's see, clear this. Okay, I mean the model itself, it's already in the as a floating, but now this one here it's not floating. Let me just try. Let me also comment this here because, oh, let's try with this half. So it's not exported as expected. So because without exporting this into, let's see, with the device, so this is the export, and I will just use, let's see, CPU. Okay, CPU, and hopefully there's no device here. So let me now run. Yeah, now you can see now it's 31 kilobyte, I mean megabyte bytes. Now let's do the detection and see the inference time. So you can see here, this is now our model, and here I have to use CPU. Okay, now of course we need to remove, let's see, comment out this. Now let's see running time on CPU. It's about 14 milliseconds. So let's do it again, and you can see 14 15 millisecond, which you can process 60 image per second. But if it's in a GPU, it's about you can process at let's see about 700 images if you use ONNX. I think that's it, and this is, let's see, a good let's not starting point, but it's a good performance comparable with many other let's see repos. They can't achieve this anymore. Thanks for watching, and see you next time.